In this video, I'm going to explain you about the properties of definite integral. Okay, so there are many properties of definite integral. The first property of definite integral is a to b fx dx is same as, if you change the variable, it will be same as a to b fz dz. Okay, the second property is that a to b fx dx, if you interchange this upper limit and lower limit, we get minus of b to a fx dx. Okay, now if we have the upper limit and the lower limit to be same, then the value of the integration will always be 0. Okay, the fourth property is that if we take a to b fx dx, this can, if you have an element lying between these two, suppose a is less than c is less than b, then this integral can be written as a to c fx dx plus c to b fx dx. Okay, so we can write in this form. Next property here we have so here we have 0 to a fx dx is equal to 0 to a f of a minus x dx. Sixth property, we have 0 to a fx dx, which is equal to 0 to pi by 2 fx dx plus 0 to pi by 2 f of a minus x dx. Okay, now 0 to a fx dx is equal to twice of 0 to a by 2 fx dx if f of a minus x is equal to fx. 0 to a fx dx is equal to 0 if f of a minus x equal to minus fx. 0 to 2a fx dx is equal to 2 0 to a fx dx if f of a plus x equal to fx. 0 to n by na fx dx is equal to n 0 to a fx dx if f of a plus x equal to fx. Minus a to a fx dx is equal to 0 to a fx plus f of minus x dx. Next is minus a to a fx dx equal to 2 0 to a fx dx equal if f of minus x equal to fx. Okay, so this is an even function. If f is an even function, then minus a to a fx dx is equal to twice of 0 to a fx dx. Okay, minus a to a fx dx is equal to 0 if f is an odd function. Okay, if f is an odd function, we get minus a to a fx dx to be 0. So these are the sum of the properties of definite integral. So using these properties, we'll try to solve the problems. Okay, so we have this is your question here. Now suppose we have this, here's your question here. 0 to pi by 2 a square cos square x plus b square sine square x. So this is your dx. Okay, so this you can take as I, you take this as I, then you apply the property 5 what we have used here. So property 5 was integration 0 to a fx dx is equal to 0 to a f of a minus x dx. So these two are same. Okay, so here I'll apply the property 5. So we get here 0 to pi by 2 a square cos square pi by 2 minus x plus b square sine square pi by 2 minus x dx. Okay, so this is equal to, we get here 0 to pi by 2 a square. What is this? Cos pi by 2 minus x is sine x. So we get sine square x plus b square. So sine pi by 2 minus x is nothing but cos. So we get here cos square x dx. Okay, so we get this. So this is equal to, so this you can give us equation 2. Okay, this you give us equation 2. Add this to 1 plus 2. You add this to equation. Okay, so if I add equation 1 and 2, what I get here? I get 2i. I plus I, we get 2i. And here we have 0 to pi by 2 a square cos squared x plus b square sine square x plus dx plus 0 to pi by 2 a square sine square x plus b square cos square x dx equal to 0 to pi by 2. Okay, 0 to pi by 2. Now what you can do between these two? So you take a square common. Between this, we can combine the integration sign together. If I take a square common here, we get cos square x plus sine square x. Okay, plus b square. You can take common, so we get here sine square x plus cos square x dx. Okay, so this is 0 to pi by 2. So this is 1, this is also 1. So we get here a square plus b square dx. So this is constant. It will go outside of the integration. We have to integrate only dx. So the integration of dx is x. So we have here a squared plus b squared x. You apply the upper limit and lower limit. So you put the upper limit first. So we get pi by 2 minus 0. So here we have a squared plus b squared pi by 2. So this implies here we have to find I. So there is 2 here. So this 2 will come down. So we get here a square plus b square pi by 4. So what is I? I is 0 to pi by 2 a square cos square x plus b square sine square x dx, which is equal to a square plus b square pi by 4. So we get here the answer to be this. Okay, now the next question, if I use this, the next question here, so we'll try to solve this. So the question here is we have to prove this one. So we have this 0 to pi by 2 sine x minus cos x sine x plus cos x dx. You have to show it is 0. We have to prove this. Okay, so how to do this? We'll use the same property here. You take this as I, so we get 0 to pi by 2 sine x minus cos x. Here we have sine x plus cos x dx. Okay, this you take as equation 1. Then you apply the property 5 here. So we get 0 to pi by 2 sine pi by 2 minus x minus cos pi by 2 minus x divided with sine pi by 2 minus x plus cos pi by 2 minus x dx. So this will be equal to 0 to pi by 2 sine pi by 2 x is nothing but cos x minus sine x divided with sine pi by 2 minus x is cos x plus sine x, because cos pi by 2 minus x is sine x. Now you take minus common from here. So if I take minus common from here, I get 0 to pi by 2 sine x minus cos x. Since it is in addition, we can interchange this. So if I interchange this one, we get sine x plus cos x dx. So when you check this by using equation 1, this is nothing but I. Okay, this is nothing but I. So this will be equal to minus I. Now you bring this one, here is I. So bring this one to this side, we get 2I equal to 0. But 2 cannot be 0. So we are forced to have I is 0. So we took I to be 0. So what is the I? I is 0 to pi by 2 sine x minus cos x divided with sine x plus cos x dx, which is equal to 0. Okay, this is equal to 0. So the next question here, I'll go to prove here this. The question is here, integration 0 to pi by 2 root of sine x by root of sine x plus root cos x. This you have to prove dx. This you have to prove it is pi by 4. Okay, you have to prove this to be pi by 4. So the first step here, you take this I equal to, 0 to pi by 2 root of sine x root sine x plus root cos x dx. Okay, dx, this you take as equation 1. Okay, this you take as equation 1. Then you apply the property 5 here. So we have I equal to 0 to pi by 2 root sine pi by 2 minus x root sine pi by 2 minus x plus root cos pi by 2 minus x dx. So this will be equal to 0 to pi by 2 root sine x, sine pi by 2 minus x is cos x. Okay, so we get here cos x. Here we root of this we get as cos x plus here we get as sine x dx. This you take as equation 2. Okay, this you take as equation 2. Add this to equation 1 plus 2. So you add this 2. So if I add this, I get here 2i equal to 0 to pi by 2 root sine x by root of sine x plus root of cos x dx plus 0 to pi by 2 root of cos x by root of sine x plus root of cos x dx. So you take together the integration, so we get here 0 to pi by 2, and you do the LCM for these two. So if you do the LCM here, we get here as root sine x plus root cos x. Here also we get as root sine x plus root cos x dx. So we can see that this and this get cancelled. So we are left with 1. So integration of dx we got as x. Then you apply the upper limit and lower limit. So we get pi by 2 minus 0 here. So we get here pi by 2. So we have 2i equal to pi by 2. So what is your I? I will be equal to pi by 4. So we got I to be equal to pi by 4. Okay, so what is your I? I is 0 to pi by 2 root of sine x root of sine x plus root of cos x dx, which is equal to pi by 4. Thank you.